we've taken a look at how to use the substitution rule to find the antiderivative of indefinite integrals. Now we're going to take a look at how to use that rule to evaluate definite integrals. Now you can either use that substitution to change the limits of the integration, or we can put the original variable back in at the end and then use the original limits. So let's take a look at the first method. So we're going to evaluate the indefinite integral by substitution, and then we're going to resubstitute the expression back in and then evaluate at the x limits. So we're going to first let u equal to x squared minus 5, and then du is equal to 2x dx. So du divided by 2 is equal to x times dx. So we're going to do the substitution, and I'm going to say that the integral of u cubed, and then x dx is du over 2. So I have du divided by 2. Notice that I'm not going to write the limits of integration because we've changed the expression to u instead. So I'm going to integrate. So I get u to the power 4 over 4. Now I don't need the c because what's going to happen is that I'm going to evaluate, and then the c's will actually cancel off. So now I'm going to resubstitute the x squared minus 5 back in to the power 4, and then this will be all over 8, and then now I'm going to put the 3 and the 0 back in now, because now we are back to using x's. So now I have 3 squared minus 5 to the power 4 over 8, and then minus 0 squared minus 5 over 8. And we can evaluate this. So we have 9 minus 5, which is 4, and then 4 to the 4 is 256 over 8. And then negative 5 to the 4 is 625 over 8. So we get negative 369 over 8. All right, so let me show you the second method. In the second method, we're going to evaluate the indefinite integral by substitution, u equal g of x. Actually, these should say 1, 2, and 3. And then we're going to use u equal to g of x to replace the upper and the lower limits by the corresponding u limits. And then we're going to evaluate the new definite integral at these new u limits. So let me show you how to do this. So we have the same question. Oops. So we have let u equal to x squared minus 5. So du equals to 2x dx, just like before. So du over 2 equals x dx. Okay, so I'm going to do the same thing I did last time. So we have u to the power 3, and then the x and the dx combine together to give us du over 2. Okay, but this time I'm going to change my limits. So we know that u is equal to g of x. So the lower limit, I'm going to go g of 0. So we're going to take 0 and I'm going to plug it in to u here. So I have 0 squared minus 5. So that's going to be negative 5. And then my upper limit, I'm going to put g of 3. So now I have 3 squared minus 5, and that's going to give me 4. So for my lower limit, now I'm going to write negative 5 on the bottom here. And my upper limit, I'm now going to write 4. So I'm going to find the integral. So I get half u to the 4 over 4. And I can place right away the negative 5 and the 4 as my limits. So I have 1/8. And I'm going to plug in the 4. So I have 4 to the 4th minus negative 5 to the 4th. So these are my outer brackets. I could have also put the 8 underneath each one. I did this one a little bit differently. So I have 1/8, and that's 256 minus 625. And that's going to give me negative 369 over 8. So we do get the same answer no matter which method that we choose. I tend to like the second one just because I find it easier to keep track and I can change the limits right away, and that way I don't have to resubstitute the x back in. And I can show you how to do this for one more question over here. So we have let u equal to 5x minus 1. So then du equals to 5 dx. So we have du over 5 equals to dx. All right, so we have the integral. So the integral is now the square root of u, and it's going to be du over 5. So we're going to use our 1 and 2 to find our new upper and lower limit. So g of 1 is equal to 5 times 1 minus 1. So that's going to be 4. And then g of 2 equals to 5 times 2 minus 1. So that's going to be 9. So my lower limit will be 4, and now my upper limit will be 9. Okay, so we're going to integrate. So this will be 1/5. And remember that you can think of this as u to the half. So this will be u to the 3 over 2 over 3 over 2. And we're going to evaluate this from 9 to 4, or 4 to 9, I should say. So here in the denominator, I'm going to rewrite that as now 2 over 15. And let's make this as the square root of u cubed. So we have the square root of u, in this case it'll be 9, and then cubed, minus the square root of 4, and then cubed. So evaluating each of these separately, square root of 9 cubed is going to be 27, and the square root of 4 cubed is going to be 8. And then 27 minus 8, we get 19 times 2, so we get 38 over 15. So like I said, I tend to like the second method only because then I don't have to resubstitute the x back in, and then I can use my new limits already.